Hello everyone and welcome back. This is Mr. Cobalt, and in this video we're going to go over some example problems. We're going to do some practice. So we're going to kind of work on this sheet here. So if you have this, you can follow along, or if you don't have this, you can just write down the element names on a separate sheet of paper and practice along with me. So this is going to be like a practice video. We're going to do some examples and you'll get a chance to practice on your own and see how well you do. So we're going to use this orbital diagram. So if you have an orbital diagram, you could use that, or you could follow along in this video, and you could pause the video and kind of use that to help you figure out what the electron configurations for the examples are. Okay, so let's start with phosphorus. So phosphorus on the periodic table, that's going to be number 15. So that means that the neutral atom of phosphorus is going to have 15 electrons because it's got 15 protons, and we're going to assume that there's equal numbers of protons and electrons. So 15, so the number of electrons is 15. So now what we need to do is we go to our orbital diagram. Sorry for the glare. I got some plastic covering here so I can use my marker. So we are going to follow the Aufbau principle. Remember, the Aufbau principle says you start from the lowest energy and you work your way up to higher energy levels. Okay. And we're going to follow the Pauli exclusion principle, which means that we can only fit 2 electrons into each orbital, and those electrons must be opposite spin up, spin down. And then, of course, Hund's rule. Remember, Hund's rule is that if you've got orbitals of the same energy, you're going to fill in with 1 electron at a time. They have to have the same spin. So 1 electron, same spin at a time before you pair them up with other electrons. Okay, so we got we have phosphorus with 15 electrons, so we're going to start by filling up the bottom. So 1s orbital is going to be spin up, spin down, so there's 2 electrons there. We're going to keep moving up, so the next higher sublevel is the 2s with the 1 s orbital, so we have the 2s orbital. So spin up, spin down, so that's 4 electrons. We have 11 more. We have these electrons, these 2p orbitals. So we're at the 2p sublevel. So we're going to fill in following Hund's rule. Remember, 1 electron at a time, same spin, spin up, spin up, spin up. And then we have more electrons. So far, this is 7. We have 15, so we got to pair them up. So that's going to be spin down, spin down, spin down. Now we have 10 electrons. We have 5 more to go. So the next energy level is going to be the 3s sublevel. So we're going to put 2 electrons in there, spin up, spin down. That is now 12, and we have 3 more to go. So we're going to put 3 in here. So spin up. Again, Hund's rule, 1 at a time. Spin up, and there you go. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that, ladies and gentlemen, is the orbital diagram for phosphorus. So now we go to our sheet here, and all we do is we go from the bottom to the top, writing down the sublevel and how many electrons in each sublevel as we go from bottom to top. So from here, it's 1s. So we have 1s and 2 electrons in there. Now the 2s, we have 2 electrons in there. Now we have the 2p with 6 electrons. So there's 2p6. We next have the 3s with 2 electrons, so that's going to be 3s2. And then we have the 3p with 3 electrons in there, so 3p3. And so that is the electron configuration for phosphorus. Okay, let's do sulfur. So let me erase this. So we're going to erase this as best as I can. Okay, hold on a second. Okay, next, like I said, we have sulfur. So we should look up sulfur on the periodic table. We look up sulfur and we see that's number 16 right next to phosphorus. So that has 16 electrons because we have 16 protons and we're assuming a neutral atom. So let's go to our orbital diagram, and this time we're going to do 16. So we're going to do the same thing. So we're starting at the bottom. So we're going to do spin up, spin down for 2. Then we're going to do spin up, spin down in the next level. And then for this one, again, we're going to put spin up, spin up, spin up, and then spin down, spin down, spin down. That's 10. We got 6 more to go. So we got 1 up, 1 down. That's 12. And now we have 4. So spin up, spin up, spin up. And then 1 more, we're going to have to pair up. So spin down, following the Pauli exclusion principle. And so this would be the orbital diagram for sulfur. And so now we can fill in the electron configuration for sulfur, just doing the same thing, working our way up from the bottom. So again, we're going to have 1s, 2 electrons in the 1s. We have 2 electrons in the 2s, which is next. So 2 electrons, 2s2. We have 6 electrons in the 2p, so 2p6. We have 2 electrons in the 3s, so that's 3s2. And this time we have 4 electrons in the 3p, so 3p4. Okay, next is bromine. Let's do bromine now. So bromine is number 35. So number 35, that means we have 35 electrons to fill into our orbital diagram. So let's keep going. So we'll just keep going from here since we're going to be filling them in again. So here we have so far the 16 electrons that we filled in. So they're going to be filled in the exact same way. This time we have to do 35. So we have 16. We have to go up to 35. So we're going to fill in the rest of these. So this is going to be spin down, spin down. So now we have 18 electrons here. We have a ways to go. So the next sublevel in energy is going to be the 4s. So we're going to put 2 electrons there. 4s is a spin up, spin down. Now we have 20. We have 15 more to go. So now the next sublevel that is the lowest in energy is going to be the 3D. So we're going to fill in those. So again, according to Hund's rule, since these are all equal energy, we are going to fill in one at a time, same spin. So spin up, spin up, spin up, spin up, spin up. Spin down, spin down, spin down, spin down, spin down. And so that's 10 electrons. So we had 20, we added 10 more. That is 30. So we have 35 electrons total, 5 more to go. So we're going to jump to the 4p. So again, Hund's rule, one at a time, same spin. So spin up, that's 1. Spin up 2, spin up 3, and we have 2 more. Spin down, spin down. And so that is 35. So if we count 2, 4, 10, 12, that's going to be 18, 20, 30, and 35. So when we write our electron configuration, we're now going to write from the bottom up. So again, starting with the 1s, we have 2 electrons in the 1s, so 1s2, 2 electrons in the 2s, so 2s2, 6 electrons in the 2p, 2p6, 2 electrons in the 3s, 3s2, 6 electrons in the 3p, 3p6, 2 electrons in the 4s, 4s2, 10 electrons in the 3d, 3d10, and 5 electrons in the 4p, 4p5. And that is the electron configuration for bromine. Okay, so what I would like you guys to do is just pause the video and then do the rest on your own, following the same strategy that I did here. So using your orbital diagram, again, figure out what the number of electrons are by looking at your periodic table, and then fill in your orbital diagram with the proper number of electrons, and then write the electron configuration from your orbital diagram. Okay, go ahead and pause the video, and then when you unpause it, I will show you the answers. Okay, so hopefully you finished and you think you got the hang of it. Let me show you what the answers are. And so this, ladies and gentlemen, are the answers to the rest of them. So compare what you have with what I have. This sheet is a little bit different. It's a different version of this, but all the elements are the same in the same order. So don't worry about that. Just check your element and make sure you have the same. And if you don't have the same, hopefully you figure out what your mistake is. I hope this is helpful. If you enjoyed this video, if this was a very helpful video for you, then please like the video, share the video, subscribe to my channel, hit that notification bell so you could be notified of the videos as I put them out. Please put a comment in the comment section if you have any thoughts or if you have any questions. Thanks again for joining me. Have a great day.